Hello NA students, welcome to the CAD/CAM laboratory. In this lab session, we are going to learn about how to create the parts of screw jack assembly in SolidWorks 2015 modeling package, and how the parts of screw jack can be assembled together, and how we can generate the orthographic views, that is front view, top view and side view of the screw jack assembly. And also we will see how the isometric view of the assembled screw jack can be extracted from the SolidWorks 2015 modeling package. In the examination, the part drawing sheet of the screw jack will be given to you. So this is the part drawing sheet. Okay, so as you can see in this part drawing sheet, the screw jack assembly is having 7 parts. Part number 1 is body, part number 2 is nut, part number 3 is screw spindle, part number 4 is cup, part number 5 is washer, part number 6 is CSK screw, part number 7 is Tommy bar. So these are the 7 parts of the screw jack assembly. When we want to get the orthographic views of the assembled screw jack, first these individual parts have to be modeled in the SolidWorks 2015 modeling package, and then individual parts, created parts, 3D parts should be assembled together, and then we have to convert the 3D assembly into 2D drawing. Then we will get our orthographic views. So our objective should be to create the should be to model the individual parts first. So now let's see how we can model the first part of the screw jack, that is body. Okay, so if you look at this part drawing sheet, so somewhere here the body is given. Okay, so this is given as part number 1 here. So this is the front view of the body, and this is the off sectional front view. Okay, as you can see here. Okay, so off section has been taken towards the right side of the body axis. Okay, so therefore off sectional front view of the body of the screw jack is given here. Okay, as you can see here, the top portion of this body is having diameter of 70 mm. Okay, and as we move down, okay, so the diameter is increasing to 100 somewhere here, and again the diameter further increases to 140 at the bottom. So therefore as we move from top to the bottom, okay, the diameter is increasing from 70 to 140, and also as you can see here on the top side, the inner diameter is also given, that is 50, and the bottom side also inner diameter is given as 100 mm. So this clearly represents that it is a hollow cylindrical component, means the body of the screw jack is having hollow cylindrical geometry. Okay, and also this hollow cylindrical geometry is not having uniform diameter from top to the bottom. Okay, as we move from top to the bottom, the diameter is varying. So whenever we have hollow cylindrical components, okay, we are going to prefer revolve feature to get the 3D part. Okay, so the revolve feature will be used. Okay, so whenever we want to use the revolve option, it is necessary to construct the profile of the body which is present towards the right side of the axis or the towards left side of the axis. So in this case, okay, the profile of the body, okay, has been already highlighted here by hatching it. Okay, so this hatched area represents the right profile of the body. Okay, therefore we should go for creating this right profile of the body towards the right side of the body axis. So therefore first we have to create, okay, this axis line, okay, in the front view. Okay, so since this is the off sectional front view, okay, so we need to create this hatched area. So this hatched area should be created on the front plane of the SolidWorks package. So therefore let me go to the SolidWorks. Okay, so this is the SolidWorks 2015 modeling package. I'm going to click on this new button here. Okay, so then I'm going to click on creating part, or then click on OK. Okay, and then okay, so you should know that this portion will be called as the command manager. So these will be called as the command manager tab. Okay, so these features tab, sketch tab, evaluate tab, so these represents the command manager tab. Okay, under each command manager tab there are different commands given. Okay, so these are the different you can see here, these are the different commands available under features tab. Okay, so these are the different commands related to sketching. Okay, and these are the different features available under evaluate tab. Okay, so therefore we can make use of different command tabs here for getting our model. Okay, so and then this portion will be called as the graphics window. Okay, or the design window, where we can construct our sketches and where we can go for converting sketches into 3D model. Okay, so this portion will be the graphics window. On the middle of the graphics window, on the top middle of the graphics window somewhere here, we have view heads up. So these will be these are actually the shortcuts which will be used for changing the orientation of the model. Okay, that is to get the front view, top view, side view, and in order to highlight the hidden edges. Okay, or in order to bring the model to wireframe, or in order to make the model as solid. Okay, so these shortcuts will be used, and also in order to zoom in, zoom out, these commands will be used. So these are called as view heads up. And also on the left side of the graphics window, so this is the graphics window. Okay, in the SolidWorks layout, on the left side of the graphics window you can see, okay, you can see the feature manager. This portion will be called as the features manager. Whatever we construct in the graphics window, those things will be listed under this features manager. Okay, is that clear? So this will be called as the features manager. So now what we have to do is and also on the bottom you can see the status bar. This will be called as the status bar of the SolidWorks layout. So this one, so status bar. In this status bar, first you have to verify what is the unit system we are adopting. Okay, so by default always the unit system should be mmgs, which corresponds to millimeter and gram and second system. Okay, so length should be in millimeter, mass should be in gram, and and then okay, time should be in second. Okay, so always you have to go for creating the sketches and models, okay, by using mmgs unit system. Is that clear? So this should be verified first. If it is not mmgs, then first change it to mmgs here. Okay, and then you can proceed for creating the sketch. Okay, is that clear? So then what you have to do is so somewhere here, okay, I am going to use white background. So I prefer white background. If you want some other background, you can use it here, something like this you can use. Okay, so you can use a different background for the graphics window, but I prefer plain white. Okay, for the background of the design window. Then what I do now is I will come to the features manager. So this is the features manager. So our objective is to create this hatched area in the front plane. Okay, so I am going to select the front plane in the features manager. Then I am going to click on the sketch here. If it is in feature, first click on the sketch. Okay, change it to sketch, and then click on sketch. Okay, so go to the sketch tab and then click on the sketch command. Okay, by selecting the sketch command, we are going to actually enter to the sketching mode. Okay, so click on this sketch. Now you can see here it is showing, earlier it was only sketch. Okay, it is like starting the sketch. Okay, once you select that sketch option, then it will highlight for exit from sketch. Okay, right now still we have not created anything on the front plane, therefore there is no need to exit from the sketching mode. Okay, is that clear? So now what we do is in the sketch tab itself, I am going to select the line command. Okay, and then I am going to draw one vertical line now. So I am going to draw one vertical line here to represent the axis of the body. So from the origin, I am going to draw a vertical line. Okay, so vertical line will be drawn from the origin up to somewhere here. Okay, I am going to click on this fit window, and then okay. So once I draw the vertical line, then this should not be the solid line, because this is actually the axis line. So somehow I want to convert this solid line to the axis line. So for doing that, I am going to select this lines, constructed line will be selected. Okay, by left clicking on it, and then okay, once we select any sketch entity, okay, on the left side we will see the properties related to that entity. Right now I have selected a line, so therefore it is showing here line properties. For this line property, okay, right now existing relation is it is vertical. Right now it is vertical, means it is at 90 degree. Okay, so now what I do is if I come down under the line properties here on the left side, you can see there is something written here for construction purpose. So I want to use this line that I have constructed right now for only for construction purpose, means it should be the axis line. So therefore I am going to click on this for construction purpose. Okay, tick this for construction purpose. Then you can see now the solid line has been converted into a axis line. Okay, is that clear? Once this is done, then what I do is I'm going to construct this hatched area now. This is the right profile of the body will be constructed. Okay, so in order to create this right profile, I'm going to use this as the starting point, then small horizontal line will be constructed, and then vertical line. So therefore I'm going to begin from this point. Okay, so therefore what I do now is I will select line command again. So by taking the alignment indicator help here, I'm going to click it somewhere here, and then first I will draw one horizontal line. Okay, so this line actually corresponds to this small horizontal line here, then vertical line will be drawn. Okay, so you need to remember I am not adding any dimensions right now. Dimensions will be added later. Okay, once we construct the rough profile, then we can give the required dimensions. So then what I do is once we construct this vertical line here, okay, so this vertical line actually corresponds to diameter of 70 mm here. Okay, means the distance from this vertical line to this vertical line is 70. But once we reach this point, you can see here there is a fillet. So it looks like there is a fillet here. If there has to be a fillet, then there should be a small horizontal line here. Okay, so that small horizontal line, okay, if you try to take the left end of that small horizontal line here, okay, that should have a diameter of 66 mm as it is shown here, because the diameter is going to decrease from 70 to 66. The meaning is that there should be some small horizontal line towards the axis. Okay, so small horizontal line has to be constructed now. So I'm going to construct small horizontal line here. So small horizontal line has been constructed, and then what I do is I'm going to construct this inclined line or the tapered line. Okay, so tapered line will be constructed like this. Okay, once tapered line is constructed, then I'm going to construct this horizontal line here. Okay, and then vertical line will be constructed. Okay, and then again horizontal line. So horizontal line should be constructed from this point to this point here. Then what we do is, so you can see here there is a fillet. So first we have to construct one vertical line. All fillets will be added later. Okay, you need to remember there is no need to worry about the fillet right now. So those fillets will be added later. So small vertical line has been constructed now, and then again horizontal line will be constructed here. Horizontal line will be constructed. Okay, let me zoom out. So here also let me fit to the window. Okay, so small horizontal line has been constructed. Then I'm going to draw one inclined line. So this inclined line has to be constructed here. Okay, so I'm going to take the help of this alignment indicator. So I'm constructing one inclined line. Okay, and again I'm going to connect to this point. So right now you can see that okay, so this line which I have drawn here has to be vertical. Okay, and that should correspond to this vertical line here, but I have not made this line as vertical. Okay, and also this particular line and these two lines should be parallel to each other, means this line and this line should be parallel to each other. Okay, and the distance between those two lines should be 10 mm. So what I do now is I am going to use first I am going to select this inclined line. Okay, and then I'm going to hold the control key and I'm going to select this second inclined line that I have constructed. Once I select these two line entities, okay, you can see line number 14 and line 6 have been selected. Okay, you can see that on the left side. Now I am going to make these two as parallel to each other. Okay, I want to add a relationship between these two lines as parallel. So parallel relationship will be given between these two lines. Okay, and also now what we do is I'm going to select this vertical line, and this vertical line needs to be what, at 90 degree. So after selecting this line here, which has to be at 90 degree. So after selecting the line, you can come to add relations here, and you can click on vertical. Okay, so this is how we can go for okay, adding some relations between the created entities. Once this much is done, now okay, so before we go for adding the dimensions, so this is the rough profile. Okay, so this is the rough profile which represents this hatched area. Okay, before adding the dimensions, what I do now is I'm going to select the origin here. Okay, I'm going to click on the origin. Okay, and then I'm going to click on this bottom end which is present here. Okay, so this bottom end will be selected. Okay, so bottom end point will be selected. So in order to select that, first select the origin and then hold the control key in the keyboard and then click on this bottom end point. Then you give horizontal relationship, meaning is that these 2 points should be on the same should lie on the same horizontal line. So I have made it as a collinear. Then what I do is I will select the top end of this axis line and this top end point here. Okay, these two will be selected and give the horizontal relationship. Okay, so now what I do is first I am going to give the dimension for this axis. So this axis dimension is nothing but it is the height of the body. So that height of the body is how much here? It is 185. So I am going to give this as 185 now. So height of the body has been defined as 185, and then what I do is I will go for giving the smaller diameter value first. Okay, once we add the height of the body, then I will go for giving the diameters of the body. So first I will select this inner diameter of the body on the top side. On the top side of the body, inner diameter is 50 mm, as you can see here. So therefore, but since we are creating only half of the profile, okay, which is present towards the right side of the axis of the body, okay, we have to enter the radius. Okay, so what we do now is I am going to select this line and this axis, and this value will be given as how much? Actually diameter is given as 50, therefore radius should be 25, or else what I will do is I will enter 50 and then I will press divide by 2. Okay, so I have given it as 50 by 2. Then what I do is I am going to give the next smaller next higher diameter value. Next higher diameter value is actually 66 which is present here. Means the distance between let me show it here. The distance between this particular point and this axis should be now okay, 66 by 2. Okay, so this is the next higher diameter value. Okay, then after 66 diameter, so the next highest diameter value is 70 here. So this will be entered. So this 70, so select this line and then this axis. Okay, so this will this radius value should be how much now? It should be 70 by 2. So therefore I am going to give this as 70 by 2. Okay, once this much is done, then I am going to give the next higher diameter value. So the next higher diameter value is actually 100 mm, which is the distance between this point and this point somewhere here, or the distance from this point and this axis should be 50. So therefore let me select which point now? This point here. Okay, and the axis. So this should be how much now? This should be 100 by 2. Okay. So once this is done, then next we have to give the diameter as again 100. You can see the next higher diameter is again 100, which is the distance from somewhere here to here. Okay, so therefore what I do is I think we have, because of the added relation, you can see the profile has gone. Okay, so what I do is see, you need to remember again one thing, that whichever the entities are appearing in blue color, they can be dragged. Okay, so what I do now is I am going to drag the profile to something like this. Later I will add the dimensions again. Okay, so therefore the profile has been adjusted by dragging the blue color lines to something like this. Okay, now I will give the dimension between, okay, this line, vertical line and this axis has how much? 100 by 2. So therefore the distance between the ear to ear should be 100 by 2. Okay, and also I'm going to give the next ear diameter as 140 now. So that is distance from ear to ear should be, it is 140 by 2. Okay, that is 70. So now it's the time for adding the we have added almost all the diameter values. Now it's the time to add vertical heights. So now I am going to add this vertical height here, 40 mm. So let me add this as 40. Okay, and then I'm going to give the distance. So this vertical height will be added now. That is the height of the base of the body. Okay, height of base of the body is given as 20. This will be added up, and then we need to give the distance between this tapered line and this tapered line here. That is the distance between these two should be how much now? It should be 10. So it will be added, and then similar to this, you can see here the distance between this line and this line, that is base, the distance between the base and this horizontal line is 3 mm. Okay, so this will be given here. So this should be 3. Now we can see that the sketch is completely turned into black color. All the entities of the sketches, all the entities of the sketch are in black color now. That represents that sketch is fully defined. So you can go to the status bar of the SolidWorks modeling package, and in the status bar you can see the sketch is fully defined now. Okay, you can see here it is showing that sketch is fully defined, means fully constrained. Okay, so therefore we can now the sketch is ready for converting it into 3D model. Okay, so therefore this 2D sketch can be now converted into 3D model. Okay, because it's completely constrained. So therefore what I do now is now I will go here onto the top left corner and I will click on exit sketch. So you have to come out of the sketching mode only when you see that, when you verify that your created sketch is fully defined or fully constrained. Okay, then you can click on exit sketch either here, or you can click on this icon which is present here. Both represents the same, that is exit sketch. Okay, so I will click it here itself, exit sketch. Okay, so and you can click on this shortcut here for changing the views. You can see when you click on this one, you will be able to see the isometric view. Okay, so when you go to the isometric view and when you click on front plane, you can see your created sketch is appearing in the front plane. Okay, so therefore we have created the sketch in the right plane. Okay, once this is also confirmed, okay, so then what I do is, and also you should see now, okay, under the feature managers, okay, under the feature manager tree, now you can see the sketch one, you can see one sketch one icon is appearing. This sketch one icon represents that okay, we have created one sketch in the front plane, and you can see here where this sketch one is created. This sketch one is created in the front plane from the origin. Okay, so I mean, okay, so therefore it is showing the relationship that we have used it for creating this sketch. Okay, this sketch has relationship with the origin as well as it has been created in the front plane here. Okay, once this is done, then go to the features tab, then you click on revolved. Okay, after selecting the sketch one, go to the features tab, then click on revolved boss or base. Okay, once this is done, since already we have created the axis, you can see the software is showing the preview of this body. Okay, so this is the preview of the body, and you can click it on OK. Sometimes what happens is, if you have not created the axis of the body, then this preview will not come. Okay, what I am trying to tell here is, if you go to this under this revolve property, now if you go to this first option here, which is appearing as axis of revolution, if I remove this axis of revolution, so if I right click here and if I clear this one, okay, and also if I clear this, okay, you can see only the which one, the sketch that we had created, but it is not showing any preview of the body. So in that situation, what you have to do is, okay, so you have to go to the axis of revolution first, and then you have to click the axis. Okay, and also you have to give the angle. So here the angle can be 90 degree. So if you give angle as 90 degree, only quarter of the body will be modeled. If you give okay, angle as 180 degree, then half of the body will be modeled like this. So then, but here we require a full the body should be there for 360-degree. Okay, so material should be filled within that created profile around the axis. So that is what you should imagine. Okay, so we created one sketch. Within the sketch we have to add the material, but how the material should be added? Material should not be added perpendicular to the sketch. Material should be added around an axis which has been defined now. Okay, so material should be added within that sketch, but okay, around an axis. Okay, so that is what this revolve feature indicates. Okay, so then click it on OK. Okay, so this is the initial draft, okay, of the our initial model that we are getting for the body of the screw jack. Once this much is done, okay, so then what we can do is we can go for adding the fillets. So you can see now we need to give a fillet here for radius of how much? 8 mm. So therefore what I do now is I am going to use, so now I will go to the features tab. Under features tab we can find this fillet command. So I will select the fillet command now, and here it is asking items to fillet. I am going to select this circular edge here, and what should be the radius here? Radius should be this radius should be actually 8 mm. So I am going to give this as 8. Then click on OK. Okay, so you can see now. So if you try to keep it in front view now, the fillet has been added here. Okay, so then similar to this we can see that there is a fillet here, and also there is a fillet here. Okay, fillet here, but for those fillets they have not mentioned the radius. Okay, so therefore if you try to read this part drawing sheet carefully, somewhere here it is given that unless otherwise stated, okay, the fillet radii should be taken as 1 mm and chamfer should be done at 1 into 45 degree. 1 mm into 45 degree. Therefore here they are not given the fillet radius of this one, this fillet and this fillet. So therefore I am going to assume it as how much now? 1 mm as per this part drawing sheet. Okay, so therefore let me select, so let me go and choose again fillet command here, 3D fillet command. Then I will zoom here by scrolling the middle mouse button. Okay, you can select, you can zoom in, and you can select this inner edge, inner circular edge here, but for here the fillet radius should be 1 mm. Okay, so same 1 mm should be given on the bottom side also. So just zoom to the base of the screw jack and try to select this edge. Okay, so you can see I have selected multiple edges now. Edge 1 on the top side of the body and edge 2 on the base of the body, and then I have given the radius of the fillet as 1 mm. Then click it on OK. Okay, is that clear? Once this is done, you can keep it in front view now. So okay, so this is how the body appears in the front view. So this is how the body appears in the top view. Okay, and this is how the body appears in the right view. Okay, is that clear? So therefore if I will try to keep it in front view now, but if you want to see the visible hidden edges, then next to the view orientation icon you have some option called as display style. So go under the display style and select this hidden lines visible. So when you click on hidden lines visible, okay, your front view, the body is going to appear in front view like this. Okay, so this is almost same as what they have given here. Okay, so the off sectional front view which is given in this part drawing sheet matches with the front view that we are seeing in this SolidWorks modeling package. Okay, and these are the hidden edges, hidden inner edges. Okay, is that clear? So this is how we can go for creating the body. And if you want to bring back the solid form, you go to the display style and you can click on this shaded with edges. So then the body is going to appear in the front view like this, and again click on this view orientation and click on this isometric option. Okay, so then the body will come to the isometric view. Now I can go for saving this body now. Okay, so press Ctrl S. Okay, or you can go to the file and you can save the file. Or you can go to the file option, and there under that file option you can use save option. Okay, so what I do now is I am going to save this file as part 1 body. Okay, because by default software will always take the file name as part 1, part 2, part 3 like that. Okay, but for easy identification, okay, when we go for assembling them, if we mention the actual name of the part, it will be good. That's why I'm in front of the part 1, I'm adding name of the part as body of the screw jack, and I'm going to save this file on the desktop. So I will click on the desktop here. Okay, on the desktop I'm going to create a new folder by name screw jack. Okay, so new folder will be created on the desktop by name screw jack, and inside that folder I'm going to save this file. SolidWorks file will be saved, and it will be saved with extension of .prt. So part 1 body will be saved here. So just click on save. Is that clear? Okay, so this completes the modeling of body of the screw jack. So next we have to look at how we can model the part 2 of the screw jack, that is nut. Okay, so now let's go for identifying where the nut is given. So you can see here this is the nut. Okay, for the nut actually they have given 2 views. So off sectional front view is given, and the top view, corresponding top view is also given. Okay, so 2 views are given for the nut here. Okay, let's see how the nut can be modeled. Okay, so now what I do is I will close this window. Okay, only graphics window will be closed. Okay, so I'm not going to close the entire SolidWorks. So if you see, there are 2 closing options here. So this is one closing option which is present exactly on the top right corner. Another one is slightly below that. Okay, so this actually, if you click on this button, it closes only this active design window. Okay, or the graphics window. But if you click on this one, it closes the entire SolidWorks modeling package. So right now still I need to create few more parts of the screw jack. So therefore there is no need to close the software. So what I do, I will close only this graphics window. Okay, and then this layout will appear. Okay, main menu of the SolidWorks will appear. So then again I'm going to click on this new part, new file. There under that I'm going to select I need to create the part file again. Click OK. Again I'm going to change the background of the working window to plain white. Okay, so then we will see now we will see how this part 2 can be modeled. So in order to model this part 2, okay, so again you need to understand what is the shape of this part 2. With the help of this front view, off sectional front view and top view, we can see here again they have given a diameter of 50, diameter of 90 and diameter of 50 here. On the top side the diameter is 50, again on the bottom side diameter is 50. Okay, and also if you look at this top view, the inner diameter is also given here. Okay, and for that inner diameter this represent actually the inner surface of this geometry is actually having a thread. That is what this square symbol represents. The square symbol represents that it's a square thread of nominal diameter of 38 mm with a pitch of 7 mm. So therefore again these diameter values indicates that, and also this top view clearly indicates that. Okay, so the top view is like circles now. So the top view in the form of circle represents that it is a hollow cylindrical component. Okay, so whenever the component is hollow cylindrical or cylindrical, we are going to again use the revolve option. So when we want to use the revolve option, we need to create we have to create the profile of the body, means the profile of the component which is present towards one side of its axis. Okay, in this case this is the axis of the nut. Okay, with respect to this axis of the nut, now this hatched area here, okay, represents the right profile. So therefore this right profile will be created first, okay, with respect to this axis, and then it will be revolved. Means within this profile the material will be added, but how it will be added? It will not be added perpendicular to it, it will be added about this axis. Okay, so therefore the modeling of this nut is same as the modeling of the body of the screw jack. So, and also since this corresponds to the front view, we have to create this right profile of this nut in the front plane of the SolidWorks. So therefore I will go to the SolidWorks, I will select the front plane now, I will go for selecting the sketch option. Okay, so then you can see now we are in the front plane, and we have entered to the sketch mode. So I am going to select the line command. First I am going to draw a vertical line to represent the axis. Okay, once this vertical line is drawn, I'm going to select that line. Okay, and I'm going to give this, I'm going to make this line as for construction purpose only. So then this will be converted into axis. Then I'm going to select line command again. So now I'm going to use, okay, so this point as my starting point on the profile. So then this horizontal line will be drawn, then vertical line. So therefore what I do, I'm going to give some gap here. Okay, so then I will draw one horizontal line, then one vertical line. Okay, and then again one horizontal line will be drawn that represents this portion. Then vertical line will be drawn, again horizontal line, then vertical line. So let me go for constructing vertical line, then again horizontal line. So okay, then again vertical line. Okay, so then what I do, again I will draw one horizontal line here, and horizontal line will be drawn. Okay, and then vertical line will be drawn. So this completes. See, you need to remember one more thing. Whenever we want to use the revolve option or the extrude option, the sketch that we are creating should be closed. Okay, we should have the closed polygon. So now we have closed the sketch. Okay, so now it's a time for adding some relationship. So what the relationship we have to give now? So similar to what we did it for body of the screw jack. First I'm going to select the origin, and I'm going to hold the control key, and then I'm going to select this bottom end point which is present on this created sketch. So these 2 points will be selected. You can see point 1 and point 11 are selected, and I'm going to make these 2 points to come on the same horizontal line. So click on horizontal. So always, so we have defined the horizontal relationship between this point and this point. Okay, means always these 2 points will try to be on the same line, means they will try to be collinear. Okay, so same thing will be done on the top side. So select this top end of the axis, hold the control key, then select this point. Okay, so then you can see point 2, point 4 are selected, and I'm going to give horizontal relationship between them. Okay, once this is done, I'm going to define height of this nut. So height of the nut should be how much here? So you can see here the height of the nut is given as 45. So therefore I'm going to give this as 45 now. Okay, so and then once the height is defined, okay, so then I'm going to define the inner diameter first. So inner diameter, see this actually, this line, okay, this inner line, vertical line here corresponds to the inner circle which is present in the top view. So this inner circle actually having a diameter of 38 mm. Okay, that is a nominal diameter. Okay, where threads are square threads are cut, okay, with a pitch of 7 mm. Therefore the inner diameter is actually 38 mm. So therefore what I do now is I'm going to select this line and this axis. So and I'm going to give the distance between this inner vertical line and this axis as 38 divided by 2. Okay, so it will take it as 19. So then what I do, I am going to give the next higher diameter value now. So the next higher diameter value is actually the distance from this vertical line to this axis, that is, which is 50 mm diameter. So therefore I'm going to select this and this. So this should be 50 by 2. Okay, so then as you can see now, as you can see, actually the distance between this portion of the vertical line and this axis should also be 50. But here this line has this vertical line has taken distance of 25 mm from the axis, but this line is at some other value. So what I do is I'm going to select this line now, and then I'm going to select this line. Okay, 2 lines have been selected, and I'm going to make them as collinear. So the moment I am going to give the collinear relationship between this line and this line, both will come on the same vertical line. Okay, is that clear? So this is how we can add the collinear relationship between the 2 selected lines. So then what I am going to do is I am going to give the next higher diameter. So next higher diameter is how much? So the next higher diameter value is here 90 mm. That is the distance from this point to this point. Okay, that is the diameter, but we are giving the radius values here. So from axis to this point, now it will be 90 by 2. So therefore I'm going to select smart dimension. So select this line and this axis. Okay, so give this distance as 90 by 2. Okay, so this is what we can do. Okay, so we have entered all the diameter values. So then we have to give the height values. So total height has been already given. Okay, but we are not given the distance, this 10 mm distance and this 10 mm distance here. So therefore the distance between this horizontal line and this horizontal line is 10 mm as per the drawing, and then the distance from this line to this line, that is collar thickness, should be 10 mm. So this will be added. So this 10 mm dimensions will be 10 mm dimension will be added for added as collar thickness, okay, of the nut. So once this is done, you can see now all the entities, all the lines of all the lines present in this particular sketch are turned to black color, indicating that sketch is fully defined. Once the sketch is fully defined, we can come out of the sketching mode. You can click here, okay, or you can click here, come out of the sketch mode, okay, by clicking on exit sketch option, okay, and you can change the orientation to isometric, okay, and you can verify where exactly we have created the sketch. So this sketch has been created in the front plane. You can see here it has been created in the front plane. Then you select the sketch 1, okay, in the sketch 1 already there is an axis and the sketch, okay, there is a closed sketch, and we are trying to add the material within this sketch, okay, but the material should be added around this axis, okay, for this profile. So therefore what I do now is I will go to the features tab. There I will use the revolve option, okay. So by default automatically the software is going to take the software is going to identify the axis as this one, and okay, and software is now it is taking as the material should be added for 360 degree. If you want to add the material only for 270, you can give 270, but we require 360, we go with 360 here and then click on OK. Okay, so this is the initial model that we are going to get for the nut, okay, but you can see here here for this collar we have the, if you try to keep here in the front view, you can see we have a flat face here. Okay, it's looking like vertical line, but in this part drawing sheet it is having some fillet here, and fillet is given on this left side. So it is fillet is how much here, radius is 5 mm. Okay, here also radius is 5 mm. So therefore fillet should be added now. So how to add the fillet? Again go to the features tab. So okay, that is features command manager tab. Okay, under that features command manager tab, go to the fillet command, okay, and then select this, you can select this circular edge first, okay, but what should be the radius? Radius should be 5 mm, okay, because it is given here, radius should be 5 and radius should be 5 here. Then we have to select this circular edge also, and then we have to select this circular edge. Okay, so we have selected, you can see here items to fillet are edge 1, edge 2, edge 3. I have selected 3 circular edges simultaneously for giving the fillet of radius 5 mm. Okay, once all the 3 circular edges are selected, then click on OK. You can see now. Okay, so if you try to keep it in front view, this is how it appears. Okay, if you want to keep it in isometric view, you can keep it and you can verify. So this is how the nut is going to appear. Okay, so this is how the nut is going to appear in the isometric view. Okay, but since it is a nut, okay, as I was telling earlier, if you look at this top view, you can see this, there is we have a small, okay, we have a thin partial circle here. So this symbol represents the what? This symbol represents the partial thin circle, actually represents the presence of the thread, okay, of diameter 38 mm with a pitch of 7 mm, and this square symbol actually represents it's a square thread, because you should know that if you have learnt in your machine drawing, okay, threads can be classified as V threads and the square threads. Okay, that is V threads are generally used for a fastening purpose, like buttress thread, okay, BSW thread, okay, and ISO thread. These are all used for those will have V shapes, and they are used for fastening purpose, or means assembling purpose. But if you want to convert rotary motion into linear motion, or linear motion into rotary motion, okay, so then we should go for using the power screws. So those power screws will have either square shape or trapezoidal shape, or okay, trapezoidal shape, okay, and under that you might have learnt about Acme thread, okay, and trapezoidal threads, okay, but simple power screw will have the square profile. So therefore here the square symbol represents that there is a power screw here, okay, and there is a thread which will have the square shape with a nominal diameter of 38 mm and a pitch of 7 mm. So that is how you need to understand. But right now you can see here, okay, the inner surface is plain. There is no thread given here. So if you try to cut the thread on the inner surface, it will take so much time for, okay, so cutting thread in the helix form from top to the bottom with a pitch of 7 mm is somewhat difficult. Okay, not difficult, but it takes time. So since we are dealing in the offline mode, okay, so we don't, sorry, since we are dealing in online mode, okay, I don't want to go in detail about how exactly that thread has to be cut on the inner surface. So instead of that, what we can do is, so instead of leaving this inner surface as plain, I can go for bringing some graphics on the inner surface which represents that there is going to tell us about there is a thread. Okay, means we can add some graphics to the inner surface. Okay, similar to earlier I was telling that if you want to change the background of this working window, you can go here and you can change like this. So this is how the background is going to be changed. Background of the working window can be changed like this. Is it not? So in the same way, now what I will do is I am going to change the graphics of the inner surface, okay, of this nut. So how it can be done, I will explain now. So you should go to you just take the cursor on the SolidWorks, then this hidden menus will be appeared. Okay, so go to this pop out menu here, and under that you go to insert, then under insert menu you go to annotations, there you go and choose cosmetic thread. Okay, so let me explain again. Go take the cursor to SolidWorks, then only you can see this hidden menus. Suppose if your cursor is somewhere in the graphics window, you will not be able to see all those hidden menus. Okay, so first you take the cursor on the SolidWorks option which on the top left corner, then hidden menus will be opened, then you go to the insert, then you go to the annotations under the insert option or the insert menu, then you go and choose cosmetic thread. So once you take cosmetic thread, okay, cosmetic is nothing but only for appearance purpose. Okay, so once you select that cosmetic thread in the property manager here on the left side, okay, it is asking for okay, from which circular edge the thread has to be cut. You can see we have to select the circular edges. So I'm going to select this top circular edge, inner circular edge will be selected. Then it is asking what should be the diameter. Okay, so I'm going to give this diameter here as I'm going to give this diameter as 38. Okay, or what I do is instead of giving it as 38, I'm going to use this as ANSI or ISO thread. There you can use machine threads here. Under that it is by default it has taken M42. Okay, you just simply go with M42 thread because we don't have option here to enter the pitch and all. Okay, anyway we are just trying to bring some graphics onto the inner surface. That is what we are trying to do. We are not cutting the exact thread on the inner surface of the nut. So therefore just go with the default values here, and then it is asking from where to where you have to give the thread, whether you have to give the thread from top face to the bottom face here, top face to the bottom face, or the thread should be only for certain depth. So here what I do is I want thread to be there from top to the bottom of the nut, so I will use through option. So once this is done, I will click on OK now. But even after doing this, okay, you cannot see any graphics on the inner surface. Still it is appearing like plain. So therefore what I do now is, if you want to see but on the features tree here, in the features tree, if you expand this revolve one sketch, under that you can see already we have placed a cosmetic thread, and this cosmetic thread has been as highlighted now in blue color here. You can see a thin blue color circle is appearing. Okay, so this actually represents the cosmetic thread, but it is not appearing on the inner surface. So what I do now is, so whenever this happens, you go to again top left corner, take the cursor onto the SolidWorks. Okay, and then okay, Okay, don't take the cursor to the top left corner. What you need to do is instead of taking the cursor to the top left corner, you take the cursor onto this SolidWorks option here. Okay, you can see here there is a option. Okay, SolidWorks options icon is available on the top menu somewhere here. You just click on this SolidWorks option, and then here you will be having two tabs. One is system options, another one is document properties. Go to the document properties, then come to detailing. Okay, click on the detailing under the document properties, then you turn on this shaded cosmetic threads. So we have to turn on this shaded cosmetic threads. Okay, and then you have to click on OK. So since here that OK option is hiding behind my behind my operating system taskbar. That's why what I do is, okay, you can see there is a OK option available which is highlighted in blue color, but I am unable to click there because it is going behind the taskbar of the operating system. So I will simply press on the enter key in the keyboard. So now the moment when we click on the enter button, okay, you can see now some graphics is appearing on the inner surface of the nut. Okay, so now you can see it looks like there is a thread. That's it. See, these cosmetic threads, this cosmetic thread is used just for visualization purpose. Okay, so cosmetic thread will tell us that there is on that particular surface thread is there. That's it. But that is not the actual thread. If you want to cut the actual thread, again modeling part will be different. That I am not going to take up now. Okay, so this completes the modeling of nut of the screw jack. Okay, so therefore I am going to keep it in isometric view first. Okay, and if you want to verify its front view, you can see this is the front view. Go to the display styles and you can keep it in you can turn on the hidden edges. Okay, so this is how it looks, and you can now keep it in top view. You can see it is looking like circles. Okay, so the top view is simply like circles now, which is exactly same as the top view given here. Okay, you can see even you can see this partial circle appearing here in thinner partial circle appearing here, which represents this thin partial circle here. Okay, so the meaning is that we have provided even the thread onto the inner surface of the nut. Okay, once you verify all this, once you verify this front view and top view with the front view and top view given in the part drawing sheet, okay, given here, okay, then we can go for saving this file. Okay, so keep it in isometric view and bring back to solid form. Okay, and then press Ctrl S and save this as part 2. Okay, so this is nut. So part 2 has been created. Once part 2 is created, I am going to close only the graphics window. Then I will try to create the part 3. So now let's look at which one is part 3. So part 3 is screw spindle. Okay, so screw spindle is given here. So on the top right corner of this part drawing sheet, only one view is given for the part drawing sheet. Okay, but within that one view, so let me rotate the part drawing sheet now. Okay, so this is my part 3. So let me keep this. So I have rotated the part drawing sheet just because spindle has to be vertical. Okay, so therefore we will try to create the spindle in vertical orientation. So I have rotated the part drawing sheet, but you can turn the page. Okay, and you can read it like this in the vertical orientation. So by keeping the spindle in the vertical orientation, you have to read all the dimensions. So now again, as you can see here, this spindle is nothing but what? So this spindle will have thread portion here. Okay, and this is the head of the spindle. Okay, is that clear? Therefore, you can see here on the top side of the spindle, there is a one more small head here with a diameter of 22 mm, and the outer diameter of the main head of the spindle is 65 mm, and this thread portion of the spindle is having diameter of 38 mm. But the square symbol represents what? On that cylindrical surface of diameter 38 mm, there is a square thread of pitch 7 mm. So that is how you need to read. So don't read this as this portion is having square shape. It is not having square shape. It is actually diameter only. But the square symbol represents on that cylindrical surface of diameter 38 mm, there is a square thread. Is that clear? That is how you need to read. So now again, as you can see, this front view, okay, of the screw spindle. Okay, so only diameters are listed here. So again, it is a solid cylindrical component. So screw spindle is a solid cylindrical component. So therefore, again, we can go for modeling this. We can model this either using extrude option or the revolve option. But I will go with the revolve option itself. So in order to create the revolve option, in order to use the revolve option, okay. So what we have to do? We have to actually create the outer profile of this spindle. That is, half outer profile has to be created. That is with respect to this axis now. Okay, I am going to draw one horizontal line, then vertical line, horizontal line. Okay, again vertical line here, and then again horizontal line, then vertical line here, again horizontal line. So therefore, with respect to the axis of the spindle, the right profile will be constructed. So let me go for creating that in the SolidWorks. So select part. Okay. Okay, so I will change the background to plain white. Okay, so that you can visualize properly. So then I will select the front plane. Again, I'm going to create the right profile of that spindle on the front plane. Okay, and then go to sketch tab, then click on sketch option, then go and select line command here. Okay, so select the line command. Okay, so then I am going to draw one vertical line for approximately 240 mm length. Okay, so 240 approximate value, and then I'm going to click on fit command here. Okay, so then I will try to create this small horizontal line here, then vertical line. So small horizontal line, then vertical line, then again what I do is I will create this horizontal line. So I will not give this chamfer right now. This small inclined line will not be created because it can be added later. So that's why I will not add it here. Okay, so first I will assume that we have material up to here. Okay, so therefore I will construct one horizontal line from here to here. Okay, so small horizontal line will be constructed, then vertical line. Okay, so then again I will construct one horizontal line here. Okay, so once this is done, we can go for creating one vertical line here up to somewhere here, then close the profile. So this is the rough outer profile, outer right profile of this spindle with respect to the central axis. So now what I do is I will go for adding the dimensions. So first I will go to the smart dimension here. I will give the dimension for the vertical center line here, which is of around 240 mm. So I am going to give the input for this line as 240. Okay, so then I will start with the smaller diameters. So first I will give the smaller diameter of 22 mm here. So therefore the distance of this line should be 22 by 2. Okay, and then what I do is I am going to give the next higher diameter value. After 22, next higher diameter value is 38 here. So therefore I am going to select this portion here. So this should be 38 by 2. So this will be added, and then next higher diameter value is actually 65 itself. So the distance from this to this should be 65 by 2. Okay, 65 by 2, and then now I will give the vertical distances. So this small portion of the cylinder is having a height of 30 mm here, 13 mm here. So therefore I am going to give this as 13 mm. Okay, and then the distance from this line to somewhere here is actually given as 83. So I will, the distance from here to here should be 83. Okay, so then what else we can give? So let me check. So the sketch should be, so it is still showing that the sketch is underdefined. So somewhere the sketch is not properly closed. Okay, So you can see almost all the dimensions we have given, but still in the status bar we can see the sketch is underdefined. So I am going to zoom out. So just try to zoom to all the corners of the created sketch. Somewhere we may have some extra line. So as you can see here, so at the origin here there is a small line constructed. Okay, when we are clicking, when we are clicking the mouse, sometimes what may happen is two lines may be created simultaneously. So that is what happened here. Okay, there is a small line created at the origin. So I am going to select that line and press the delete key so that it can be deleted. Now once we delete that small extra line that was created, you can see the sketch has been fully defined now. So I am going to exit from the sketch now. Now I am going to I will go to the features tab. There I will use the revolve option. Okay, but now since we have not created an axis, so the software is not automatically taking about which line the material should be added. Okay, so therefore here axis of revolution is not selected. So manually I am going to pick this vertical line. So then we are going to get the preview. Then click it OK. So this is the preview of the screw spindle. Okay, is that clear? But this is just a initial model, but for this still we need to make a hole here, we have to add chamfer here, we have to make another hole here, which is so you can see here there is a countersink hole, okay, with V bottom, and this hole is also having thread, and it is a M12 thread. Okay, so all these things has to be added. Okay, and they have given here is that there is a diamond knurl given onto the outer surface of this head of the spindle, but knurling, all these things cannot be given. Okay, so at least we will try to add this hole, and this countersink hole will be which one, threaded hole will be added, and then we will add the chamfer. So these are the remaining features we have to add with respect to this model. Okay, so first let me add the chamfer. Okay, so you can see here there is a chamfer here. So this chamfer is having dimension of 10 mm height into 45 degree. Okay, so therefore what I do now is I will go for, so go to the features tab. There under the fillet command, you can see the chamfer command. Okay, select the chamfer command now. It is asking about which edge the chamfer should be made. So therefore I will select this circular edge and this circular edge. So these two circular edges will be selected, and by default you can see distance is 10 mm and angle is 45 degree. You can see here, so distance is 10 mm, 45 degree. So in our part drawing sheet also the distance is 10 mm and angle of chamfer should be 45 degree. So therefore the default values are matching with our chamfer chamfer dimensions given in the part drawing sheet. So therefore I will simply click it on OK. So once we do it, you can see, so in the front view, okay, you can see the chamfers. Okay, is that clear? Or you can keep it in isometric view, you can verify. So this is how we can add the chamfer. Okay, so once chamfers are added on the top and bottom side of the screw spindle head, okay, so then we will try to make this hole here. Okay, so there is a hole. So this hole is having a diameter of 12 mm and it is a through hole. So therefore what I do now is in order to make this hole, first let me keep this model in the isometric view. So I'm going to select the front plane. So I will select the front plane. In the front plane I'm going to create a sketch now. Okay, so and I will change the orientation to front view, and then what I do is I will select a circle command. Okay, under sketch tab. Then I'm going to draw one circle here, somewhere here. Okay, for this drawn circle I'm going to add dimension of 12 mm. Okay, but still this sketch is showing in blue color because it is not completely constrained. Why it is not completely constrained? Let me show. Okay, so when you try to move this one, you can see we can move the entire circle to anywhere. Okay, in the front plane. But where this circle should be, the center of the circle should be collinear. The center of the circle should collinear with the axis of the spindle. Okay, so what I do, I will select the center of the circle, and by holding the control key I will select the origin. Okay, so this origin is nothing but it is a point on which the axis of the spindle is passing. Okay, so therefore these 2 points will be selected, and I will give the vertical relationship now. So the moment we give the vertical relationship between center of the circle and the origin, okay, so you can see now if you try to move the circle now, only possibility is we will not be able to move the circle either to the left or right. Only possibility is it can be moved up or down. So what I do now is I need to constrain I have to restrict the vertical movement also for that circle. How it can be restricted? From this bottom edge here, okay, of the head, okay, from the bottom edge of the head of the spindle, okay, this center of the circle should be at a distance of 35 mm. Okay, so that is what I am going to give now. Go to smart dimension, select the center of the circle, okay, and this bottom edge of the head of the spindle. So this distance should be how much? 35 mm. So once you give this distance as 35 mm, you can see the sketch is completely in black color, means it is fully defined. Okay, and you can change the orientation to isometric now, and you can see now, you can see here where exactly that sketch 2 is created. So sketch 2 is created exactly at the middle of the spindle. You can see, means it is created on the which plane? It is created on the front plane. You can see there it is created on the front plane. Okay, once it is created, select the sketch 2 now. Now go to the features tab. Okay, so now we have to use this extruded cut option. Select the extruded cut option, means we have to cut the material, okay, within that created circle, and we have to cut the material perpendicular to that sketch. Either in this direction the material should be cut, okay, or in this direction. But right now in the part drawing sheet it is given that it is a through hole, means the complete material. So on either side of the created sketch the material should be removed. So therefore what I do now is in the property manager I am going to use through all option, through all both option. Okay, on both the side of the created sketch we have to cut the material. So use through all both, then click on OK. Okay, then you can see, okay, so the wall has been created. Is that clear? Okay, but in this part drawing sheet actually only one wall is shown, but in reality there will be one more wall placed perpendicular to this, means in this direction, in this transverse direction, okay, in the horizontal direction one more wall should be cut exactly at the middle, so that we can easily insert the Tommy bar. But here they have not mentioned in the part drawing sheet, but I will show it here. So in order to cut one more wall perpendicular to this wall here, okay, in the horizontal plane, so what I do is I will select the right plane. I am selecting the right plane, then I will go for sketching in the right plane by using sketch option. Then I will change the orientation to right view. Okay, then I am going to select circle command. I am going to construct one circle here, and I am going to give the diameter of this circle as how much? 12 mm. Then the distance from the center of the circle to this bottom edge of the head is 35 mm, as we did it earlier. And I am going to select the center of the circle and origin simultaneously. Okay, so these 2 points will be selected, and I will give this as vertical. So then you can see the sketch is completely constrained now, and it is appearing in black color. So you can see where exactly we have created that. So if you try to keep it in isometric view, you can see we have created this, okay, on the right plane. Then come out of the sketch plane. So once you come out of the sketch plane, you can see sketch 3 is exactly placed somewhere here on the right, at the middle of the spindle head on the right plane. Then by selecting sketch 3, go to the features tab, select the extruded cut option. Okay, again we need to cut the material within that sketch on either side. Okay, so therefore use through all both option. Okay, we have to cut the material within the created circle, and we have to cut the material on either side. We have to cut the material towards the left side as well as towards the right side. So therefore use the through all option, give it OK. So this is how it appears. Okay, but in part drawing sheet again I am telling they have given only one wall. Okay, so practically there will not be one wall. Okay, so there will be 2 walls, okay, which will be perpendicular to each other on the horizontal plane. So therefore it looks like now there are 4 walls made. Okay, is that clear? Okay, so let it be like this. Then our objective is to make this wall, okay, which is actually the countersink wall, because somewhere what is meant by countersink wall? So as we move in the direction in the depth direction, the diameter is going to decrease. Okay, so that is the countersink hole. So on the top side the diameter is more as we move in the direction of the depth. Okay, so in this direction, in the depth direction, the diameter has slightly decreased, and then again the diameter is remaining uniform for the remaining depth, and then at the bottom of the hole there is a V bottom here. Okay, V shape is here, and you need to understand here that okay, this hole is actually having a depth of 35 mm. Okay, out of 35 mm depth, okay, for 30 mm depth, okay, for 30 mm depth out of 35 mm hole depth, for the first 30 mm depth from the top side, okay, M12 thread has been given. Okay, means thread in this 35 mm depth hole, okay, tapping has been done. Okay, for 30 mm depth. Is that clear? So therefore it is a threaded hole. Okay, or it is a tapped hole. Okay, so therefore how to add the tapped hole, I will show it now. Okay, so in order to add the tapped hole, we need to use in the features tab, we are going to use option called as or the command called as hole wizard. This should be used. Okay, so this hole wizard option should be used. Select the hole wizard. So once you click on the hole wizard, on the left side you will see the hole wizard properties. Okay, so here we have two tabs again. Under hole specification we have two tabs. Type of the hole should be selected first, and then we have to select the position where that selected hole should be located. Okay, or placed. So therefore first we have to select the type of hole required, and then we have to specify where that selected hole has to be placed. Okay, so therefore first let me select the type of the hole. Okay, you can see here when you take the cursor on this icon, it is counter bore hole. Okay, it is countersink hole. This one is actually the simple hole. This is actually the straight tap hole. Okay, this is actually tapered tap hole. Like that, different types of holes are given here. Okay, so I am going to use a straight tap hole because it is not a simple hole. That hole is also having a thread on the inner surface. So I am going to use this which one? Straight tap hole. So select the straight tap, and then once you select that straight tap, come down. Okay, in the feature manager. Okay, so in this properties manager is simply come down now. It is asking we are trying to select ISO hole. Okay, ISO thread hole. It's a tapped hole again. Okay, so then again it is we want to use the M12 thread. Okay, it's already selected. Otherwise you can use different value. So I want to go with M12. Okay, if you don't want to use the M12, okay, you can use the M10 like that. But in the part drawing sheet they have mentioned here it is a M12 M12 threaded hole. So therefore I am using M12 here, and you can turn on custom sizing if you want. Okay, so I will turn on custom sizing here. Okay, so here the inner diameter M12 means the inner diameter should be 12. So therefore I am going to give this inner diameter as 12 here, and the bottom this whole bottom should have whole bottom face should have okay V bottom, that is angle at bottom should be given as 90 degree. By default it will take 90 degree or 118 degree, whichever you want you can use it. Okay, I will go with 90 degree, and then end condition. Okay, so end condition is that here we can specify what is the hole depth. So actually the first one, this first one actually indicates, you can see here it is the hole depth, blind hole depth. Okay, what is the hole depth? Hole is there for a depth of 35 mm. Okay, so this is what I was telling earlier, 35 mm, and then thread is there for a depth of how much now? Only for 30 mm. So that is how we have to read. So you can see now it is a tap thread depth, that is thread depth. So here it should be 30. So this should be given. Okay, is that clear? So then whether you require near side countersink. Yes, we require near side countersink. The meaning is that this countersink. Okay, but what is the actual larger diameter on the top side, we don't know, but we know that inner surface should have diameter of 12 mm, but outer surface should have if you want to get the countersink type of hole, the outer diameter should be larger. Okay, so it should be greater than how much? 12 mm, but it is not specified here. But what we do is you can see this the distance from this line to this line is it is 12 mm. Therefore the outer diameter should be in between 12 and 22. So what I do now is, since that data is missing here, I am going to give this diameter value here as around 16 mm. Okay, it is slightly greater than 12 mm. Okay, so I'm going to use this as 16 mm diameter. That is the near side countersink diameter. So countersink diameter is not specified in the part drawing sheet. So I'm just taking it as slightly greater than how much? Slightly greater than the inner diameter. That is 12 mm. Okay, so therefore I have given here 16. So once you set all these whole specifications, then come to position. Now we have selected tapped wall, we have entered the wall depth, we have entered the thread depth, we have entered the countersink diameter value. Okay, and also we have selected the V bottom. After selecting, providing all these wall specifications, come to the positions. Positions means where it has to be placed. Now, okay, so I want to place it over this flat face here. Is it not? We want to place this wall on this top face. So therefore, I am going to select this top face. Okay, once I select, you can see now, okay, a preview is appearing. Okay, you can see there is a preview appearing in yellow color. So, but where exactly it should be placed? You have to move the cursor on the on this outer circle first. When you move it, you can see the, so let me change the view. I will keep it to top view. The moment you take the cursor on this circle here, okay, you will be able to see a plus mark, okay, at the center or at the origin. Okay, that indicates the center of this circle. So once that center symbol appears, take the cursor there and click there. Okay, so then you can see now, okay, you can keep it in isometric view. So you can see we are trying to place, we have placed one wall, okay, exactly at the center of that top circle. You can see, if you want, you can also go for placing another wall here, another wall here, but we don't require them. So I am going to click it on right symbol. So you can see now, okay, so wall has been countersink wall has been created. Okay, and as you can see, we gave the thread specification as how much? M12, and you can see here on the left tree. Okay, that is under the feature managers. Okay, under the feature manager. Okay, you can see M12 thread wall has been done. Okay, and wall is also wall thread is also mentioned here as 30 mm. But we are not visualizing any graphics here on the inner surface. So, but we have already made M12 tapped wall, but there is no visualization for the presence of the thread on the inner surface of this wall. So what we do now is we are going to again click on this whenever you cannot see the graphics of the thread, you just go to the SolidWorks options here, then go to the document properties here, go to detailing, turn on the shaded cosmetic thread, then click on OK by entering it. Now you can see here, okay, once you do that, you can see the on the inner surface you can visualize the thread. This is just for visualization purpose. Actually, we are not made any, we are not cut any thread on the inner surface. This is just for visualization purpose, only for imagination purpose. That's it. Okay, but means just we have added some graphics to the inner surface of this wall, countersink wall. Okay, so if you have any doubt, you can go for, so just on the left side of this view orientation, okay, you can see there is an option called as section view. You can go and click on, click on this section view, and you can keep it in front view here. Okay, and click on OK, and you can see this is how it looks. Okay, so this is how the spindle is going to look when you are going to take the full sectional front view. Okay, on the front plane. So this is how it looks. Okay, if you don't want to see the section, you just again click on this section view icon, it will disappear. Okay, so this is how to take the section. So this is just to confirm whether you have given the countersink wall or not. Is that clear? So this is one way to see the section view, and if you want to turn off the section view, again click on the same shortcut here, that is a shortcut icon of the section view. Okay, so we have placed the wall on the top face of the spindle head. Okay, so then what we have to do, so almost this completes the modeling of spindle, screw spindle. Okay, this completes the modeling of the screw spindle. but you can see we cannot give the knurling and all, just ignore it. But you can see here, this is the this portion is the portion of the screw where threads, external threads are placed. Okay, so here we add in internal thread. Okay, that is metric thread, that is V threads. But here in the thread of the screw spindle, okay, thread portion of the screw spindle, we have to give the square thread of 38 mm with pitch of 7 mm. Okay, so therefore, but here so this face, so this particular lateral face of the cylinder should have thread, but here it is not appearing like there is a thread. So what we have to do, if you want to show graphically there is a thread on this outer surface of this rod. So what you have to do is again you have to go to insert option here, go to annotations, go to cosmetic thread. Okay, and then again it is asking from which circular edge you have to give the thread. So I am going to specify this bottom circular edge here. Okay, so from this bottom circular edge, okay, I have to give the thread, you can see here, from this bottom circular edge, the thread should be given up to somewhere here, but there is a 3 mm, see, the total length of the rod is from here to here. Okay, but thread is not cut for the entire rod length. Okay, so for 3 mm length of the rod, there is no thread cut somewhere here. So therefore, for 3 mm, we should not provide the thread. So how it can be done? So you can see the total length is 240. Out of 240, you subtract 83 and also subtract 3. So 240 minus 83 and minus 3, that is 240 minus 86. Okay, will give us the effective length of the rod over which we have to give the external thread. So therefore, what I do now is, okay, so once I select this as circular edge, so then I am going to give here M38 should be selected. So M38 is not appearing because it should be lower than 38. So I am going to go, I will simply go with M36, and also we don't have option here for giving square thread. We simply go with which one, metric thread itself. Okay, so then I am going to use this as blend. Okay, so blend option, because I don't want to give thread for the entire rod length. If you want to give the thread for entire rod length, you can use this through option. You can see here, the moment we select this as through option, for the entire rod length, okay, thread graphics is appearing, but we don't want to give it for the entire rod length. It should be blend. We have to give only for a certain defined length. Okay, so what is that certain defined length? It should be 240 minus 83 minus 3. So therefore, I am going to give this as 240 minus 83 minus 3. Okay, so when I do that, it will take automatically as 154. You can see now only for 154 mm length from the bottom end of the which one, screw spindle thread has been placed. Okay, then click it on OK. Is that clear? So this is how you can give the thread graphics onto the outer surface of this rod of the spindle. Okay, screw spindle. And also, if you look at carefully this part drawing sheet, okay, for part number 3, as you all know, the bottom edge, the bottom circular edge should be chamfered. Okay, and again, unless otherwise mentioned, we should go for chamfering. We should go for giving chamfering for 1 mm with 45 degree. So therefore, what I do now is this bottom circular edge should be chamfered, because so that it can be aligned easily when you are go for inserting into the nut. So therefore, what we do now is I will go to the fillet. Under that fillet option, I will use chamfer option. I will select this bottom circular edge. Okay, and the distance, the chamfer length should be 1 mm. Okay, and chamfer angle should be 45 degree. Then click on OK. So once you do that, you will be able to see here. Okay, you can see here. So just let me try to keep it in front view. Okay, you can see. Okay, so 1 mm chamfer has been made for 1 mm distance and at 45 degree. So this completes the modeling of actually which one? Modeling of screw spindle. Okay, so then we can go for saving this. If you want to verify its front view and top view, you can verify. So this is its front view. You can go for turning on the hidden edges. You can see here. Okay, so you can see here we have given the thread. So this thin inner lines present here represents the presence of thread, and there is a hole, okay, and there is a countersink hole. Here you can see there is a countersink hole. So all these things you can verify in the front view by turning on the hidden edges. Okay, is that clear? But if you want to bring back it to solid form, click on shaded with edges. Then you can change the orientation to isometric. Then press Ctrl S and you can save this as part 3, that is screw spindle, and save it. So this completes the modeling of part number 3, that is screw spindle of the screw jack.